All right, so this one's going to be a review on dividing, and there are 4 ways to divide. Number 1, you can just divide up, and that is when you are dividing by a monomial. You can factor and cancel, and we should be professional factors by now. And then there is synthetic division, and that's when you're dividing by something that's like x plus 5 or x minus 3. It cannot have a coefficient in the front, and it cannot have a power. And this is on what you're dividing by. If none of those 3 methods work, then you have to do long division. The reason that I'm going over these skills is because this is used in calculus, but it's used as a step in a bigger scheme of a problem. So you don't want to miss a problem because you get hung up on the algebra. Go miss a problem because you missed the calculus, but don't miss it because you missed the algebra. So we're just kind of sharpening those skills a little bit. Okay, so 1, 2, and 3, I'm just going to do one of them. You're just dividing up, so you're going to divide and subtract your exponents. There you go. Piece of cake, not a problem. The factoring and canceling, you know, we all know that you can't cancel this stuff because they're married. We all remember that from pre-cal, that you have to factor. And we all are professional factors by now. Let's see. I don't think there's one. This one, number 7. When you factor the top, these 2 pieces really want to cancel, but you can't because they're backwards, but you can throw the -1 down, and that allows you to cancel them because it takes that 2 minus x and makes it an x minus 2. Just remember that that -1 is now a part of your answer. You can write it either way. It doesn't matter to me. Sometimes it matters to the problem, but you just kind of have to figure that out on a problem-by-problem basis and see which fits better. And all the problems I skipped are just different types of factoring. Number 3 has cubes. Number 4, squares. There's a GCF on the bottom, and then this one is 2 GCFs top and bottom. Synthetic division, and again, you can tell on all of these, I am dividing by x plus something or x minus something. No coefficients and no powers. To do that, I always put the solution to that on the shelf. So some people always say it's the opposite sign, you know, however you want to think about it. You do need to watch out for holes on the top. That's a 3, a -1, a 2, and a -4. Then you drop your first number, and then you multiply. So 3 times 3 is 9, and then I add down. Always add down, so -1 plus 9 is 8, and then I do 3 times 8 is 24, and add down. That's 26. And 3 times this 3 on the shelf times 26 is 78, I think. And then add down that 74, and then you always shelf him off. That guy that you shelved off is your remainder. Work your way back up. This is going to be your constant. He's going to be your x. He's going to be your x squared. If you had more, you'd keep going. The way that you write your answer is 3x squared plus 8x plus 26 plus 74 over what you divided by. I don't have tons of room, but I want to show you the setup, and maybe go ahead and do number 3 because it has a hole. So x plus 1, so I'm going to put a -1 on the shelf, and then I go x to the 4th, x to the 3rd, and it misses an x squared. So I'm going to go 1, -2, and then I'm going to go 0 for the x squared, a 1, and a -1. So you have to fill in the holes of any terms that are missing, and that includes the constant, the guy way down here at the end. I'm going to drop and then multiply and then add and then multiply and then add and then multiply and then add and then multiply and then add. So I have x to the 3rd minus 3x squared plus 3x minus 2 plus 1 over x plus 1. Synthetic is weird, but it's super easy. Synthetic like if you think about synthetic fabrics, I mean, it's a man-made. So this is sort of a man-made trick for an escape route, sort of, to not have to do long division. So long division is when you're dividing by something where you can't factor and cancel and you can't do synthetic. So if I'm going to look at number 2, I'm going to skip number 1. Again, this is review, so I'm going to just do a couple of these. So I'm going to divide, multiply, subtract, and drop. That is the cycle. There we go. So when I divide 3x into 3x to the 4th. So what does that need to be multiplied by to get to a 3x to the 4th? That's an x cubed. And then I multiply, so I've done my division. Now I'm going to multiply, and when I multiply him by both of these. So that's going to be 3x to the 4th plus x cubed. So I've multiplied. Now I'm going to subtract, change both my signs. These should cancel always. 7x cubed minus 1x cubed is 6x cubed. And now I drop. And then I do the cycle all over again. So now I'm going to divide this term into this term. And so what does a 3x need to be multiplied by to become a 6x cubed? It needs a 2x squared. Now I'm going to multiply him by both of those. So 6x cubed plus 2x squared. Now I'm going to subtract. And those are going to cancel, and that gives me 3x squared. And then I'm going to drop. And then I'm going to divide again. So I'm going to do 3x into 3x squared, and that just needs an x. And then I'll multiply. Notice I've got to have signs in between up here on my answer. So if it's a positive, then you just put a plus. 3x squared plus x, if I do the x times the 1, and then I change both my signs, those cancel. Negative 9x, and then I drop my last term, which means this should be the last cycle. And I divide 3x, let's see if I can pick another color. 3x into negative 9x, so that's going to be a negative 3. Multiply, so negative 9x minus 3. Change both your signs, those cancel, and that's a 10. That's my remainder. Hook it in with a plus sign and put it over what you are dividing by. There he is. So yeah, there you go. There's long division. Pain in the butt, but a necessary evil. Feel free to try this one or this one. Just jot them down on a scratch sheet of paper, and then if you want to shoot me a picture and ask me if they're